just what's been going on. I mean, this is data for 1 month, but it's the beginning, and whether we can see trends already. I mean,
And this is obviously before the jet stream took a little bit of a gainer.
which was interesting because I know that now it's kind of like, well, wait, the first month of January, I mean, the red is in like North Dakota.
Right?
It,
And northeastern Montana.
what is that? I mean, I think that's just is it's January, but then the next month, I know we don't have the data for it yet, but it's like
The
polar
next
opposite.
month, it's like freeze your asses off. I
I
mean,
want
but if you look at the southern, tier of the U.S., it's quote unquote in January was near basically at normal temperatures. So
which
yeah,
is interesting, but really the red and the above average temperatures is in the Dakotas and Montana, like you said. A little bit of Maine, New Hampshire, that region. That was a shout out to you. Okay. Um, okay, I'm just losing it over here. The precipitation, just looking at it, because um, I don't know if there's a parallel, the warming of North Dakota. I mean, there's no rain. It's drier than average up in those states, north of the Dakotas. The impacts is just strange weather can impact crops, I'm guessing, like that type of situation.
well, what's the trend will be is that dry areas as climate changes, dry areas will get drier, wet areas will get wetter. For
Right,
example, if you have a dry region, it's going to do what? You're going to suck the moisture out of the ground,
right.
but there's still not enough moisture in the atmosphere because then, of course, you got air movement, it moves it away to cause precipitation. That's one of the reasons why, Arctic fires are becoming more and more prevalent because the air is warming up, but the air is dry, it's sucking the moisture out of the ground, making the ground itself dry and more vulnerable to going up, to going on fire. So it's another feedback loop, a positive feedback loop. So that's one of the mechanisms there. Where if you have a wet area, well, you got a lot of moisture, you precipitate out, the moisture goes right back in the atmosphere, precipitates out, and so on. And also, don't forget the role of the jet stream. That with the meridional flow and the temperature and pressure gradients not being as sharp, the jet streams are moving slower. So they tend to stall or go slowly over it. Now think back to when, was it Harvey, the hurricane that
Right.
hit Texas? It literally stalled over the state and just pissed away on it.
Oh, I know the pictures coming from that were just the
Hey,
highways.
people, how's living in Texas working out for you?
I know they're getting hit if you think about it, like year after year. I know people are still moving there.
But that's kind of the general notion of what's going on. The with the meridional of jet stream flow, it's going to be slower.
I see.
That's another, and if it's going to be slower, yeah, it brings the cold air down, but it kind of is going to leave it there. So you have to wait, as the planet starts tipping, the axis starts tipping more and more towards the sun, where you can start getting increase in the heat energy. You can wait for the stuff to break down.
There was another point the website brought up. It was the idea that because that area is so warm in the Midwest, the Great Lakes. Do you know anything about like the issue with the Great Lakes and like how less ice is covering it, or
Oh,
that's
so well, yeah. I mean, the Great Lakes not freezing over, basically.
right, that kind of issue. Like the Great Lakes are possibly dying as well. Oh, basically water sources are at risk. That kind of issue.
It's chances are because of the excess heat
Okay.
that it takes, because you have a specific heat of water, which means it holds more latent heat energy, that it's going to take longer to give off that latent heat so that the water itself cools down to the point where it can freeze. Now, that's interesting with the lakes because pretty much fresh water is going to freeze at 0 C. Unlike the Arctic Ocean, where you have salt, you have salinity, so
Right.
you have to cool the water down past into, 0 C into negative temperatures before you can even start getting some what we call grease ice to form.
Oh, interesting. Right.
So basically, what I'm trying to say is it takes less energy lost to form ice in the Great Lakes than it does in the Arctic Ocean. So the fact that they're not icing over is troubling
Right. And I know,
because
like,
then what?
yeah,
Because then what
no,
happens
it's
is now
fun.
you have open water, you have that moisture going up into the air, and you get what's called lake effect snows. We basically just get pummeled with wet, heavy snow.
And I know there has been incidences lately where like these absurd numbers of like right by the Great Lakes, the snow amounts are like humongous. Like
Yeah,
they're not
yeah,
normal.
yeah, 4 feet in 4 feet in 12 hours kind of
Yeah, that stuff.
stuff. Yeah,
So maybe
exactly.
the connection is the water. There's more it's the moisture, right? Like that whole
Hmm.
issue.
Yep.
All right. The connecting the dots. No, it's if it wasn't so like extinction, it would be fun, but it's so
And
funny.
of course, warmer air can hold more moisture. So,
Yeah,
because
it's
people
like
say, "Oh, look at all the snow. See, this isn't climate change."
that's yeah. I've heard
Well,
that.
it is climate change because, first of all, we're still tilted away from the sun at this time of year. But second of all, warmer air holds more moisture.